All right, geographers, we're going to talk some database design, get into what's happening kind of under the hood of all sorts of different GIS maps, products, whatever that you've used or will use or all that stuff, and hopefully with this introduction, it'll get you thinking about how you would go about setting up your own GIS. Okay, that's from, and when I say setting up, I say GIS in that kind of singular idea. If you, and this is why I hate the name GIS, why we should have come up with a better, sexier name for the whole thing, but it's a geographic information system as I was using it there, right? Not the systems, not that plural thing, but if you want to create your own system for some kind of big project, like what I'm showing you here, right? That's the whole idea behind this. And what I'm gonna do with this is I'm trying to show some practical examples. And it's not perfect. I'll explain that as we go, but it'll work. And I think that's a big important thing with learning about database design and just data concepts. It's so often with just GIS stuff, it's taught, or at least it was in my past experience, it's taught in this very abstract sense, right? You get into database design concepts and theory, but when you're just a little baby geographer and you're trying to make sense of all this stuff, for me it was like, I don't what and why, and it didn't make sense. So I'm going to try to point out some practical examples as we go through this so that hopefully it will click. All right. And I'm also, as I go through here, I'm going to be referencing the Modeling Our World textbook, the second edition that I had you guys purchase and read. And specifically, we're going to talk about the first chapter and the third chapter as we go through this stuff. All right. So that's the plan. Okay, so what we're looking at here, why I've brought you here today, what we have up on the screen is one of these US topo maps. This is the Lancaster West one. So this is the thing. I mean, those of you listening to this, you've probably already seen these things. Hell, you've probably heard me talk about these things already. But the idea, in other classes, right? But the idea is we have these topographic maps for all over the country produced by the USGS, and at a certain point, I forget when the exact moment was, but at a certain point, the USGS switched from doing these hand-drawn cartographic products to this GIS-based map that we have here. And the cool thing with this is that these can be updated in a much more rapid manner because it's all connected to a database and can be pulled out quickly. You don't have to have somebody sitting down or a team of people drawing stuff and adding stuff. It's much easier to maintain these things. So that's the cool aspect. It does miss, I'm not totally thrilled with these. It misses some of the artistry from those past products, but some of those past products were pretty out of date and you had to wait quite a bit of time before they would produce new ones. So this works. All right. But the idea with these, let me zoom out a little bit here, is that all of the different things in here, whether it is the map stuff itself or even the things around the side of the map, around the collar here, it's all database driven. And with these digital products, if you don't print this thing out, but you bring it into a PDF viewer, if you have this layer capability, like with, Acrobat can handle this, you can actually turn these things on and off because, they're GIS layers, right? So things like the road features, if I get rid of this, if I click on the creepy eyeball, I don't even like clicking on it because it's just, right? But if I do that, you can see like the 14 disappears. All these little arterial and collector streets and all that stuff disappears, but everything else stays there, right? I can turn those back on. Sorry, eyeball. I can turn off the railroads, and then that disappears. All right, so that's kind of the cool thing. But in order to do this kind of stuff, you really have to be planning ahead of time. It wasn't like, one day somebody at the USGS said, hey, wait a second, let's make this a GIS product. And they just kind of started and slowly pieced stuff together. No, it would have been, not that I know, I've never worked for these folks, but it would have been a planned effort. It would have taken years, I would imagine, to get to the point where you could even begin to make the switch, because you would have carefully planned this system out. All right, now I don't have the exact details of what the USGS did to switch this to a GIS product, but the next best thing, I've got this guy right here. Let me zoom out. Let me maximize that, and we'll come out a little bit. So this is this ArcGIS 1 to 24,000 scale base map data model right here. We have scrolled across the top, and it's a PDF that I have loaded in Canvas for you guys to look at. Now, this is not a USGS thing. This is some Texas thing. All right, where do we have? Yes, this data model example was created for the Texas Natural Resources Information System. Okay, so it's a different entity, but you get the idea, right? I thought it would be good to show that USGS one to give you a sense of, what's being discussed with this whole topographic base map data model concept. And it's even the same scale, this 1 to 24,000. So it works. Okay. Now with this model, what this shows, this is the master plan right here. So this was everything, how it was conceived before you started inputting actual data into the system. Before the system even became something, it was planned out in this way so that you could make sure it was done right. This is big. I mean, this is done for all of Texas. Texas is big. I don't know if you're aware. It's a big place. They like to bring that up a lot. But it is big, and there's a lot going on. It's a massive state, massive amount of territory, a lot of people there. So this isn't something you just kind of, on a whim decide to do. You want to plan this out. So you don't waste your time and realize as you're going through that, I should have done this. It'll just take longer, right? If you don't have a plan. But also B, you don't want to do all this work and then say 3 years down the road, realize that, oh shoot, you know what? Yeah, I should have done it this way. That would have saved a lot of hassle, but oh well, got to rebuild the thing. Right? When you're doing this, you're trying to anticipate every possible need, issue, change, that kind of stuff. And it might not work out. You might have something that you never even thought about down the road. But at least you hopefully, if you design this properly, you at the very least, if you do have to make a change, you've set it up so that change isn't going to be that drastic. Right? Or there are ways to make these changes easier. And so I'm going to go through here and point out some different things. And I'm also going to go into ArcMap to show you this whole geodatabase concept. And as I said, I'll reference that Modeling Our World book to make this all work. So first, let me zoom in over here to these thematic layers. And it's somewhere, I have it marked in Modeling Our World. Where is it? Yes. Oh, beautiful. So on page 18, well, that's second edition. You can see that first bold header thing at the top of the page. Design starts with thematic layers. All right, that's what we're looking at right here. So these thematic layers, this is like, chapters of a book or they're categories. That's what we're seeing here. So this first one, reference, all right, map use, location finding, data source, where are you getting this stuff from? So there's our USGS, got the ArcMap graticules, public land survey system. Well, that's interesting because Texas, well, they didn't use the federal system as far as I know. I could be wrong, but I thought they were never part of that because they're Texas. But whatever, I'm not going to question this. I don't want to make Texas mad. But so you get the idea. It's explaining, okay, here's this group of stuff, the reference things. And you can see with this image right here, and isn't this cute? It's like layers getting squished together to give you that full GIS vibe. But you can see the little tick marks and, graticule stuff in here, all of that. That's this stuff. So in fact, let's just go back here as another example. If we're, again, not the same thing, but kind of the same thing, we've got latitude and longitude and UTM in here. We've got, various tick marks. We also have the public land survey system. We can turn that on, right? And we've got township and range and sections and all of that. So that would fit into this reference concept. Then we have transportation. Represent how goods and people move between destinations. So you can see, some of this stuff, it's kind of like, do you really need to define transportation? But it can be useful to make sure that you work with this definition right off the bat to ensure that you know exactly what you're talking about. You want to have these good definitions. What do I mean by this thing, right? So transportation might sound obvious, but maybe you're just thinking, you hear transportation and you're thinking about people moving between destinations. So you think about roads on which cars are driving, right? But goods, that can get into other stuff like shipping, on actual ships or railroads and things like that. You might not think about it if you haven't defined this whole transportation idea as being, goods and people. And there's a lot that can go in there, right? So that's the idea with that. Cultural, administrative, hydrography, hypsography, fancy. So there's water, right? Fancy way of saying water. This is representing terrain. We're getting into elevation, right? We're getting into the high points, the low points, the relief. That's what we're talking about there. Surface overlays. So getting into raster stuff, image, so some kind of aerial thing. And then this page layout design gets into, and you can see, there, it looks just like the USGS stuff. That's why I think this works okay here, but you can see the north arrow, and I'm sure that shows where in Texas we're actually looking at, and just that map information, okay? Oh, look, it even says organizational standard based on USGS, 1 of 24,000 products. All right, so the first step that you're gonna do, and this is what you can read through with that first chapter, is and so on, what page did I say that was? 18. All right, so it gets into these thematic layers, but then on 19, it also gets into this whole, the 11 steps to designing geodatabases. That, if you read through that, that'll get you thinking a little more on this stuff, right? And like, exactly what do I need to do here? All right, but what I'm going to show you, do we go through, is just to kind of make this practical here, let's see, let's pull up ArcMap. I'm going to start to build something like this too, to show you how it connects to a geodatabase. Now, you don't want to do this until you're set, okay? The building the geodatabase should be the last part of it, because, and believe me, I've been there, so this is how I know if you start just by building one of these things in Arc Catalog here, you're going to forget stuff. You're not going to think about stuff. You're going to wind up deleting a bunch of stuff and having to rebuild it. Okay, so I'm simply showing you to just kind of connect some of these things. But remember, you want to have some plan. Let me go back here. You want to have the equivalent of this. You don't have to make some beautiful poster, but you want to have all of your thematic layers mapped out. I'm going to talk about the different features that are shown in here, and domains and subtypes, and all these things that are in here. So I'll get into what those are specifically, but I just want to kind of go back and forth to help you connect these things. All right. So we have our thematic layers. So the idea, let's do catalog, and here is you want to have some kind of table, or folder, right? Not a table, a folder where you're going to save all of this stuff, some place where it's going to exist. I have this little database design lecture folder. I'm just going to use that as an example. If I right click on there, go down to new, I've got these options. All right. And I've got a few different geodatabases. What you want to do is use file, personal, It's an old kind of primitive thing. It's built off of Access databases. It's not really necessary. It's not as good as these file geodatabases. It's there, at least as I'm recording it with, version 10.8 or whatever of ArcMap. It may go away at some point, but really for what you're doing, you don't want that. It's not worth it. You want to use this file geodatabase right here. So I'm going to make a new one of these, and it just says new file geodatabase. I'm going to give it a beautiful name. In fact, just to go along with this, let's call it Texas. There we go. Just thinking. There we go. Okay, then I can right click on here. So think about this geodatabase. It's this. In fact, let me not right click here. So with this right here, they have this silver cylinder icon. It's like a container. I don't know what it's supposed to really represent, like a silo or a bucket or a trash can. I don't know, but it's a silver container. Just think of it as this is going to hold your whole system right here. All of the important data, tables, relationships, things like that. It's all going into this geodatabase. All right. Now, another thing I could have done here, right click, new. You can see, there are a bunch of different options here. We have shape files, which is what, if you're, my GIS students, you've mainly been working with shape files in my classes. And the reason why you've mainly been doing them is because they're easy to send through Canvas and email and work with our archaic network system and all of that stuff at AVC. Shapefiles are easy because they're primitive. They're ancient files, and so it works, and it doesn't freak out security and virus stuff and all that. So you'd have a shapefile to represent some roads or cities or state boundaries or whatever it might be, and that's great, but it's limited because that's all it is. And so if you want to have, I don't know, a bunch of stuff like all of this Texas stuff that we're dealing with, you would have, I don't know, 100 shapefiles that would be independent of one another, and it would just get unwieldy. The geodatabase, it contains everything in there. That's why we want to use that. That's why this is the goal. And I would be doing it. In fact, all of my classes are built off of geodatabases that I then had to quickly convert to shapefiles because of fun with IT. All right, so that's the issue there. Okay, so right click on them and go down to new. And I can create a new feature data set. And I'm going to go ahead and do that. And this feature data set, you can think of this as these thematic layers, right? It's an easy way to keep stuff together here. That's why I use it quite often. It's just to make sense of things, but I'll show you. In fact, let's just say transportation. Let me spell it right because it's going to bug me. Any OCD folks watching this? So transportation. Okay, good. So give it a name, what it is. And I think, with all this stuff, I don't even think it doesn't give you any hints in here. With this, it's better than dealing with like shape files or these dbase tables and stuff like that in terms of naming and headings and things like that. But I still try to be simple with this stuff. So avoiding spaces, using an underscore if you need to do that. Not using any special characters. You might be able to do it, but frankly, I've just had so much, bad luck with that stuff, going through the different iterations of ArcView and then ArcGIS and all these things that you learn to keep the stuff as simple as possible. All right, then for this feature data set, you're going to define a coordinate system right off the bat. Okay? And that's great because it kind of forces everything you're working with in here to exist in that same coordinate system. And that's useful when you're dealing with, if you remember from your Geography 205 class, with geoprocessing, when you're really getting into manipulating the data, comparing different data sets with one another, you want to have everything projected into the same coordinate system to limit the possibilities of error, right? So in forcing stuff into a feature data set, it just forces you to have everything work nicely together, if that makes sense. So I have what I usually use with like Southern California stuff is the NAT 83 UTM zone 11. We're saying Texas. I'll just stick with it. Should I or should we? Let's stick with it. I'm not gonna get creative. We'll just use that. We'll call it good. Deal with it, Texas. They've got some other system they use in here, but we ain't got time to look that up. So I'm just gonna pick. Oh wait, did not select it. Hold on. Okay, we're good. Okay, all right, we're good. Okay, then saying, hey, what about vertical stuff, right? X, Y. That's so two-dimensional. What about the Z stuff? What about that third dimension, elevation, stuff like that? And with all this, don't get too freaked out by it if you're just doing some local thing. If you're not actually doing some hardcore 3D modeling or whatever, you don't need to stress. We're going to go ellipsoidal based because this geoid stuff I don't trust because I'm an old 20th century kind of guy. Let's click that, North America. I'm going to pick this NAT 83 right here. And we've got, right here, linear units, meter. So it's going to be my XY's in meters, my Z's in meters. This will be fine, right? So I'm just going to do that. And if I really had to be paying attention to this stuff or was, really doing some, like I said, some hardcore three-dimensional modeling, then I'd look into it a little more. I'd worry a little more about it, make sure everything worked together perfectly, or I was using the best one, talk to other folks. This is going to be fine because I'm just showing you stuff and I rarely work in 3D stuff anyway, so we're good. These XY tolerances, you can leave the default. Again, it gets into one of those things where, you'll know if you need to change it. Somebody like a boss will tell you, make sure you do this. Or if you're doing research before you do this, you'll find that stuff. But honestly, all of these default tolerances are fine for what it is most of you guys are going to be doing. So I'm going to hit finish and boom, I've got this transportation thing in here. Right? And what I could also do, let's just do this quickly. Let's see, cultural, just to kind of show more than one of these things. Cultural, yes, we're going to do that. I got to find that. Okay, we'll just, we'll keep it the same because it's all going to be in the same area. There's no reason to change it. But again, it'll be like a chapter kind of thing in here. Right? So now you've got these little plus things here, but there's nothing in there. But what you can do is right click to new, and we've got feature class. And so a feature class, it's a point, line, or polygon concept. It's like a shape file, right? If you want to think of it that way. So I can make a new one of these, give it a name. So I would just do something simple like roads. Alias, this is for when you add it in. So in the database itself, like this is the actual feature class that's being saved here, but the alias, what you're doing is it's what it's going to look like in the table of contents over here when it comes in, right? So this is where you can be a little more creative. In fact, it's it's Texas. So I'm going to say roads, y'all, right? It's roads. I'm going to make that a linear thing. So line, not going to worry. I mean, maybe you'd want to do routing stuff in there if that's what you're planning for some kind of transportation thing. I'm not going to worry about it. Hit next, default, fantastic. And then in here, now here's the deal. You're not locked into stuff because you should be able to add a field as you're editing. I think you guys have most likely done that and working through tutorials, exercises, or whatever. You can add that into into the table later on. But this is where you're going to decide, what do I need in here? And just to make sure we're connecting all this stuff, let me come back here to our model and let's scroll. So we got transportation. So we've got this roads, carto, dissolve, right? Which is funny. This cracks me up because this is the kind of thing I would name something because it makes sense in my brain. Clearly, it's a roads layer that was dissolved using the dissolve tool in ArcGIS, right? So that you don't have these different, individual line segments in each road, which those are great for like the routing stuff, for geocoding, for that kind of stuff. But sometimes you just want a pretty roads layer so you can just see it, right? For reference. So that Carto, I think I've used that exact phrasing in past stuff I've used, where it's saying, look, it's the dissolved thing to look pretty from a cartographic perspective. That's what that says right there. And you can even see right here, contains M values? Nope. Z values? Nope. You've already figured out, okay, what is it that this needs to be right here, right? And then here, these field names, this is that part of that design. This is what you're thinking about in terms of what does my feature class need to have in that attribute table. So a few things here, like object ID or OID, you don't need to worry about that. In fact, if we come back here, that's already populated in there. And this object ID, it's a unique key or identifier. It's something that is unique. So each road in here, each line in this thing is going to have a unique number assigned to it. That's what the object ID is. It's a number. It's an integer we have. So, 1, 2, 3, 4. These will be different entities to help the computer make sense of this stuff, but also just to ensure that every single separate feature within this feature class is unique. So even if it has the same road name, even if it has similar values throughout, it's going to have that unique object ID. And to make sure we humans don't screw it up, the computer takes care of all of it. All right. The shape geometry thing right here, that's another thing. We don't need to worry about. The computer's going to take care of it. Oh, hang on, let me do that. So yeah, right here, this shape geometry, don't need to worry about it. But then down here, this MIN underscore name string, I guess, whatever this means. And that's an issue. As you're going through, as you're designing this stuff, if you're going to have clever codes in here, you should have some documentation that explains what that is. Either metadata that you build and attach to the geodatabase, which we can talk about later on, or at the very least at this initial setup, you should have a notebook. You should have a Word document, Excel file, something where you're keeping track of all these different little codes, because it might make sense to you, but that doesn't necessarily make sense. I mean, it's got name in it, but you might worry, like, is that the right name thing? Is this something I'm not aware of, right? So you want to, as you're designing this stuff, any codes you have, spell it all out later on. And I'll talk about metadata later, all right? Data type, string, so that means it's text is what that's referring to. You're going to type out. So it's the name of the in fact, maybe it's the name of the street. Maybe that's what STR is. I don't know. But it would be, Main Street, Elm Street, that kind of stuff, right? Allow nulls means you allow no data in there. You don't have to actually type something in. Maybe it's an off-ramp or some part of road that really doesn't need a name attached to it. You're not going to be forced to give it a name, right? And that can also be useful from a cartographic perspective. Just limit, the names that already exist in there. So with this, the string, you can see integer, double. To make sense of what these things are, so again, where this modeling our world, second edition, comes in handy. And that's in the third chapter, I believe. I think it's like page 66. Yes, this is where we start to see these things explain the difference between a short or a long integer, string, double, float, that kind of stuff. I also, in the geodatabase building PDF that I have in Canvas, I've spelled some of that stuff out for you. I give you examples of that because it can be daunting. Like, what the hell is the difference between a double and a float and the integer? And well, it's all numbers, but it handles this stuff differently. Okay, so use modeling our world. Like I said, page 66. It helps explain that stuff. And as we continue, nothing here, nothing here, nothing here. This 255, that's the amount of characters that you have. So you could type, right? 255 characters. You get to the 256th one, it's done. Okay, and this used to be really important when storage and personal computers was just not that great, because you could always add, you could put 1,000,000 right here, but it's just going to require more storage space in the computer, right? It's not, you don't have to stress about it too much, but you do want to definitely think about how much do I really need here. Honestly, no street that I know of would have more than 255 characters, I wouldn't think. And even then, like, let's abbreviate some of that stuff, because that's getting ridiculous. And let's even petition to rename the street, because that's stupid. All right. So for most of our streets, that's more than enough. A few lengthy exceptions in there. Sometimes the names of people, like Martin Luther King Jr. Boulevard. I ain't got time to count that. I don't know how long this is, but that's a long one. But I bet you 255 is no problem, right? And even then, you could get, creative with how you name this. You follow? Okay. All right. So let me go back in here. So that's what this stuff is. So that name thing, I'll just say name. And in this case, it's text, means the same thing as string. You see these other things in here. And then length, that's what that is. So I can do 255 to change that, to default to 50. Allow null values, yes, right? I have two options. And then this default value, typically you don't want that, because whatever I type in here, as I put in a new road, it's going to default to the name being whatever I put in there. You don't, with something like a name that's so unique, you don't want that. All right, but that's what all this stuff is. And you can continue. You can just keep adding stuff in here and as you go. Right? I'm not going to do any more, but you get the idea. I'm going to hit finish. And look at that. Check that out. Roads, y'all. That's just down home fun. But with this right here, you can see it brought it in here. It says, I don't know, blue or green line or whatever, but I ain't got nothing over here. It's because I ain't got nothing in here. All right. If I open the attribute table, you'll see there's my name. So that object ID, shape, and that shape length, it's calculated once you actually start editing this stuff, draw stuff in. And you can see that if we come back here, shape length. So see the blue or lavender, whatever that is, you can't touch that. This is what you have control over. Okay, is that, we following that, making sense? Fantastic. But that's the idea. This is what it would eventually look like. And you can, with this, to bring stuff in, I mean, editing and digitizing and all that's, it's beyond this little video here, but your options are, you could go in and start drawing stuff, right? If you use right click, edit features, start editing, you get into all this stuff. Let me get my, and I have to, well, my thing's not, where's my, well, okay. You know what? I'm not even gonna worry, but you could draw it in here. Okay. That's the general idea. In fact, I'm trying to, let's just, if we do, it's going to bug me. They changed edit, like since like back in the day, there we go. This is create features. That's what we want. It used to be, yeah, dang it, kids. It used to be, you right click and you start editing and you could start editing. Now it's, you got to click these buttons and hibbity hobbity. There we go. Okay. So here's my road, because it's out of, God dang. Okay. Because forget it. Don't worry about it. This is what I get for just quickly, making believe in here. Okay, but that's one way. Or you can copy and paste from another existing thing. So like in here, let's see, I think. Yeah, so it's designed from the roads, ramps, and major highways based on the VVT _ ID and name attributes. Blah, 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 blah. But wherever that source data is coming from, what you could do, like you're not expected to create a whole new road network from scratch, right? But I could get an existing road data set from the Census Bureau or from the specific county or city or whatever I'm working with. I can just click on those, copy those things, and paste in this editing environment, assuming it all works and is happy and all that stuff, and start bringing that stuff in, populating stuff, and getting it from there. That's the general idea. The other thing I could do is you can copy stuff directly into your feature data set. If that works, you just need to make sure that the projections, the coordinate systems all work together. Okay, but that's the idea with that stuff. All right, hopefully that's making sense as we go through this. Now, one thing, well, actually, let's get into something a little. I'm going to use this LandCover because it's got a few more things I want to point out. But let's talk about this LandCover domain thing. We also have that with transportation in here, but I'm going to keep it simpler. I looked at this earlier. This LandCover one's a little simpler, and we can talk about topology as well, because these are two more things I want to discuss with you as you are looking at this stuff and thinking about it and so on. Okay, so we have two concepts here: subtypes and domains. All right, which are kind of the same thing but different, so it gets kind of fuzzy. Good news, your chapter 3 of Modeling Our World gets into both of these things. But the general idea with a subtype is that, hey, you've got a general category of stuff like roads. The example that we just had, we can have different, all sorts of different types of roads. Right? So they're all roads, but some of them are interstates, highways, arterial roads, local roads, ramps, on ramps, off ramps, things like that. All right. And when we're drawing this stuff, in fact, let's go back here to our example that kind of works, but not totally. We have Highway 14 running through the Antelope Valley, as well as it's also technically is 138 for part of it in here, as you can see. But this is, if you're AVC students, if you're local here, it's a highway, it's a freeway, it's a big thing that runs through there. So it's drawn with this thicker line weight and the red color and all of that, right? Whereas some of these other ones in here, these smaller, let's zoom in, 17th Street West, 16th Street West. These are smaller little things. So they're drawn with this different, color, line weight, all that stuff. Even the ramps are handled differently on here, right? So that's the idea with a subtype, and why it's useful is you could have one transportation, or not even transportation, one road, that road carto dissolve thing. Right? But you can specify these subtypes and say, okay, some roads are going to be these big freeways, and we're going to want to be able to quickly find them. Hey, sometimes it's just nice. You want to say, okay, where are the freeways at? Do a select by, attributes or whatever it might be, however you're going to do it. So you can find it, right? Sometimes from a cartographic standpoint, you want to make it a different color from something else. You want it to stand out or blend in or whatever it might be. That's going to be useful, right? Because you can tell it in the symbology. Okay, if it's this subtype, draw it this way. If it's this subtype, draw it that way. Okay. Your other option is to simply have multiple feature classes. You would just simply have a freeway feature class, and then an arterial feature class for like West Avenue G and these little, local collector streets. You'd have a separate feature class there. And there's actually, your book even has, I don't even know, is it here? Oh, beautiful. Page 71 of your Modeling Our World, second edition. It gets into this question of, should you use subtypes? Should you use multiple feature classes, right? And there's no one right answer. I've had projects like back when I worked for, planning departments and doing just kind of these kinds of maps where I needed good reference maps. I would use both. Sometimes I just wanted to have all my freeways in a nice dissolve separate thing so I could slap those babies on, didn't even have to think about it, right? But I also needed a more master total feature class to make it easier for things like geocoding or some of this other stuff, or just to have everything in one place for, analysis, for asking questions of the data. So if we go back here, in fact, hell, I'm still talking about transportation. Let's go down here. Maybe it's useful to have a roads carto dissolve, but it's also useful to have just a roads, right? Roads complex, something like that, where it's not this nice dissolved, for rapid map rendering and labeling, but it's the original data where it's got all this different stuff in here, right? And maybe you simply have one that's freeways, and but what you're doing here is you want to have some kind of rationale behind it. Why do I need this thing? All right. You don't want to make some big bloated thing just because, but instead you want to think, okay, you know what? Sometimes it's going to be easier to use this roads thing. Sometimes it's going to be easier to use another one, right? That's the idea. That's what you should be thinking about here as you're putting this stuff together. Okay. Now let's go back here to this LandCover example because it's a little easier, a little simpler and easier to look at. So this type right here, integer so it's a number. Okay. Allow nulls. No, it's got to be something here. And then default value gives you a default. All right. Which the default value 250. I'll get into what that actually means. And then it's got this domain of LandCover. All right. So here's all this stuff. Let's break it down. So the number really it's connected to another table effectively is what we're dealing with. And we can see it right down here. So in the database, it's the idea that the LandCover type, it's going to be a number that happens. So you can see down here, 250, forest or brushland, 251, scrub, 252, cropland, and so on. So it's going to default, just automatically populate forest or brushland for whatever reason. I don't know. I guess maybe that's most of the stuff is going to be that. So that's why you would do that. You're not going to have mainly lava throughout Texas. So that's just, a separate one right there. All right. So with this, you're tying to, from here, tying to this. So if it's simply a subtype that you're doing, you could have a separate table. This would be the proper way to do it. Rather than having type in here and you can just write whatever. Typically what you would do is you'd make it an integer and then you would have another table, a separate table that you could join or relate to. All right. You guys have done that step before just to kind of make this cleaner and to make editing and changes easier down the road. Okay. So if I really need to worry about types, I could join something, in here from this subtype table that I have. So I could, figure out, okay, because I can't remember what a 254 is. It's scattered trees, right? It's our reference to have it in not computer speak, but something that makes sense to us. But what's great about this, if I make a mistake or I need to add something or change one of these or whatever, maybe I get to a point where I decide I don't know, this orchard or plantation, plantation with Texas, that's charming. But let's say I decide, you know what? No, I want to have either orchard or plantation. I can make changes in here, right? Just, once or twice in there. I can add another one. 260 could just be plantation. I can make that orchard. Now, of course, I'm going to have to change these numbers in the original one, but still it's going to be a little simpler, a little more streamlined. Or also maybe I decide, you know what? It's not vineyard that we want. It's another term we want to use or something like that, right? rather than have to go through every single entity in here, I change it once and it's connected once. That's the rationale behind this stuff. And it's also, like I said, it's just to keep it kind of cleaner and neater. Now, the domain concept, it's a related concept, but it's specifically saying there's a range of values that you're going to be allowed to choose. And that's it. You can't type in your own stuff. So like with, you can't put in 272 or something for your value here. It's not going to allow it. It's gonna be one of these 10 options that we've got. Okay, it's gonna force that, and we saw that like when I was playing around with the in the geodatabase thing, the adding what was it? I think it was like allow null values, and it said yes. If I clicked on it, it also gave you no. Right, that was a domain right there. You couldn't type in maybe, right, or like I don't know, or something like that. You had to either pick yes or no to ensure that stuff doesn't fall apart. So when we're using a domain, what that's referring to is it's not just a subtype, but it's fixed. You don't have options, if that makes sense. And these can be very useful for like if you have something specific like land cover in here, or transportation, like we know, like I was saying, it's going to be a freeway, arterial collector, that kind of stuff. If you only have specific options here, then using that domain functionality is great because it's going to eliminate mistakes. It's also going to eliminate like spelling issues. That can be a real pain. I'm sure you guys have dealt with this in here, where if you're going through sorting things, trying to select by attributes or do some kind of query or whatever it might be, if some things are misspelled, or sometimes it's it's spelled this way, then it's abbreviated and all that, it can just be a nightmare. And if you haven't done it, you'll get to that point. You'll inherit some database that you've got to like make sense of, that's just been kind of Frankenstein pieced together over the years. It's awful. So that really makes you appreciate this idea of the domain. All right, so that's the concept there. Another thing too, this allow nulls, where it says no, it's the idea that you're, with LandCover, it's gonna it's a LandCover feature class, right? So you're basically saying like, no, whatever I'm putting in here, it has to have some type of LandCover, otherwise it doesn't belong. All right, so that's where that not allowing a null would be useful. You just don't want to have, polygons out there. And I know it's a polygon because of two things. We've got this little icon, means polygon right there, but it also says geometry, polygon, right? Look how handy that is. So that's all part of what these things are. But yeah, you think about it, like, why am I editing in a polygon if I'm not going to assign it some kind of value here, right, for LandCover? So that's that whole null thing. All right, and then in here as well, actually, two things here. Now we'll call it one thing here. We'll do two things. We'll go ahead and do it. All right. Just trying to think of how long I've been doing this and if you guys care. But no, this is good stuff. This define a M:1 relationship class and a layer, many to one is what that should stand for, unless they're doing some weird, funky stuff. But with these relational databases, and we say that when we have multiple tables and entities in here that relate to one another, that are connected. I just realized I'm moving my hands yet again. You guys can't see this. But the idea, like this domain, how that's connected here and so on. With all of this stuff in here, it's related in some way. And we have within this database design in general, relational database design, we have three possibilities. We've got a one-to-one relationship. And so an example of that is, because these always make sense with examples. Like if we take the college example, one student is going to have one unique student ID number, right? You get that. At every college you go to, they assign you some unique number, right? So you can have multiple students at a college, right? That would be a many to one relationship. One college, many students. That's what we're getting at here. But with students, there has to be that one-to-one relationship for that ID number. Because if we didn't have that, you go to get your transcript or even sign up for classes or whatever, and if you're sharing the same ID number with 10 other students, it's going to be a disaster. It's not going to work out. So that has to be one-to-one. But then many to one, like I said, many students to one college. You can also have, if you reverse it, one to many. And that the example, you could just reverse that. One college has many students, or one teacher has many students, right? But those many students in that class, they have one teacher for that class. That's the idea. So that's what this is getting at. That's what that means. That was what we're talking about. But then the other thing here is this topology deal. And you can create these. Let's go back into catalog. I think if I just do new, I do in here, yes, topology in here. Oh yeah, because I have roadsy all in there. It's saying can't do it. But that's what you do. But what topology is, it's a rule. Okay, it's some kind of rule for how these things within the feature class are going to relate. All right, so this LandCover right here, it has a separate topology, and I would build that into, like I showed you there. If I would have, I really should have just stuck with this as the example, but what the hell, here we are. But if I had in here, let's close this, we're not toolboxing. So if I had this, here's my Texas thing, and then I right click, and made a LandCover data set. And then I would also have a LandCover, in fact, hell, let's just do it. Hopefully you're watching this at like 1.5 speed. I'm talking really quickly, so you're not bored out of your mind, but let's just call it LandCover and do next. And yes, okay, we're going to do this, and yeah, probably should have saved a favorite. Let's do that. Yep, we'll do our little thing there. Fantastic. Love it. Beautiful. LandCover. And then I would right click and I would have my feature class, and that's called land cover alias LandCover y'all exclamation point. It's Texas polygon, right? And you see polyline in there. That's used line. It's the same thing in here. So polygon features. Now let's see. You can even see here contains M values, Z values. No. So do there default, and I could put in here, all this stuff. This is where I could enter that stuff. I'm just going to do this to show. So I've got my LandCover there, but I could also right click, new topology, right? Because it's in the thing. But that's where this feature data set becomes useful, right? In fact, is it the editing? Is it? No. Okay, it's just because it's there. Now let's try this. Let's just try it. All I want to do is show my students. Can I do it now? New. Yeah. Oh, now you're happy. Look, thank you, wizard. Let us build this. So what we can do in here is we can build these rules. And this one, you enter a name. Yes. Cluster tolerance. I don't know. Does that look precise enough for you? Fantastic. We'll just leave it there. What's going to participate? So if I had multiple ones, maybe I could make a rule for, a bunch of stuff in here, but I only have the one. So I'll just hit that. Okay. Number of rank, you can, decide, you can basically plan out, what's going on here in terms of multiple things going on. I just want to show yes, add rule. So this says LandCover must not overlap. That's how that works, right? And so it's a way to insist, to force, or what it'll really do is it'll show like you screwed up, basically, with this stuff. But with LandCover, right? You're not going to have some of it you could get into some nuance and like ecotones and zones of change and all that. But let's just use the lava example right here. lava. It's either lava or it ain't, right? It's not going to be like kind of lava, kind of forest, because the lava, you just think it's cut off. And yeah, you could have some erosion and weathering, and but still, right? It's the rule here is like, look, are you lava or are you forest or are you scrub? You're not cropland and scrub, right? You're going to be one. So you don't want to have these things overlap because that can screw up if you're doing analysis down the road. Okay, and so finish that. Yes, I know, because I don't have features. Look, just back up. But it shows it right there, right? And so you can see how I'm keeping all this stuff together in here. That's the idea. That's what makes this geodatabase. Apart from being able to do some cool stuff with it, it's nice that everything kind of lives in this one area. It's nice and neat. Okay, and then if you scroll all the way over, see an annotation, just so you know, it's labels. Just to, because it kind of place labels. You guys take the cartography stuff, you'll get into that. But all the way over here, this is showing, like what I was kind of building over there, what you're gonna see. So it's showing, and it's showing the annotation, the labels, the rules in there, this line thing, this polygon thing, all these different things in there, right? That's one data set, and that connects with these themes over there, those thematic layers. And you can see our other stuff. You know, there's our transportation. Do we not see LandCover? Did I go past that? Where the hell's our LandCover? Maybe they got tired. I don't know, but you get the idea. It would have all that. I don't think they fit that anywhere else. I don't know. Very tired. Okay, surface overlays. So sorry. That's where it fits. That's what it's not LandCover, y'all. It's surface overlays. So there you go. Right? That's how it's going to look. So the idea, especially as you're planning your own big, massive relational database for your own geographic information system, this is the kind of thinking you need to do, right? The planning out. That's the key thing. I wanted to show you this stuff to get a sense of how it all connects, but the real artistry here is this planning process where you're figuring out, hey, what's going on, right? What is happening here with, what I'm trying to show, what I'm going to need to do? Do I need these topological rules? Do I need to have, would it be better to have some kind of annotation thing so I can just quickly throw this on and I don't have to have that dynamic labeling that can be problematic sometimes, right? What kind of fields do I need inside my different feature classes that I have? That's what you're planning out and justifying all of this stuff and thinking about, what's important and what isn't. Does that make sense? Hopefully it does. I'm tired. So yeah, hopefully it makes sense. If it doesn't, play it again. I'm sure it'll work. And if that doesn't work, talk to me. We'll get through it. All right. Happy mapping, geographers.